Okay, so Birappa, let's proceed ahead with the technical snap for thermodynamics. You are a student in final year, right?
Yes, sir.
G. Pullareddy Engineering College, GPREC, right?
Yes, sir.
Okay, so Birappa, when we say about thermodynamics, how many laws are there in thermodynamics?
So I know that it was 4, sir.
4 laws are there.
Yes, sir.
Okay, can you tell me the significance of zeroth law?
So zeroth law significance, it doesn't it means that temperature, sir. It tells about the temperature.
You know, there is something which is called thermometric property. Are you aware about that? Thermometric property?
No, sir.
Thermometers are always based upon thermometric property. Like mercury thermometer, you must have seen at home.
Yes, sir.
So you know that length is the terms in terms of which the length we measure the thermometer temperature. You know that?
Yes, sir.
Do you know something about gas thermometers?
No, sir.
Gas thermometers?
I didn't see, sir.
Constant volume gas thermometer, constant pressure thermometer. Have you heard about that?
No, sir.
Okay. Anything you can tell us about second law?
Second law of
Thermodynamics, yeah.
Second law of thermodynamics deals with the entropy, sir. So in second law of thermodynamics, we have 2 statements. That is a Clausius and Kelvin blank statements. So Clausius tells about the the temperature does not transfer the from low temperature to high temperature. That's called a Clausius statement. That coming to the Kelvin blank statement, it deals with the that means no engine can be that means design without the sink or anything. That means some heat of maybe heat or maybe another energy, it will be some loss will be there. Without any loss, we can't build any engine. So it tells about that something.
How many minimum thermal reservoirs should be there as per Kelvin Planck statement?
Minimum reservoirs, sir.
How many minimum thermal reservoirs should be there?
The minimum reservoirs should be 1, sir.
Minimum should be 1.
Yes, sir.
So with single thermal reservoir, you can transfer heat into work.
Yeah, we can transfer, but some loss of will be placing when it is come heat to transfer from heat to work.
When you will reject the heat, obviously there will be sink.
Yes, sir.
So that means it will be 2 reservoirs.
Sir, we have one reservoir. Another one is called sink.
So that reservoir sink is also reservoir. Other is called source.
Yeah, okay. I don't know actually what
Source and sink both are reservoirs.
Yeah, okay.
Can you tell me what is so special about thermal reservoir?
Sir, can you repeat?
What is special about thermal reservoir?
Special about? No, sir.
They have infinite heat capacity.
Okay.
Okay, can you tell me, Birappa, how do you calculate the efficiency of any heat engine?
Sir, efficiency of a heat engine is output by input. You know that.
And what is the output in engine?
So output in engine, that means work developed by the engine. So input, it is called the work given to the engine.
Work is of different types. You know that PdV work, VdP work.
Yes, sir.
Can you tell us something about PdV work and minus VdP work?
So PdV work depends with the when we the engine. I mean the engine when we teach in the form of graph, that means PV graph. So the vertical lines will be on. I mean the area occupied by the vertical lines, that is called PdV work, and the area occupied by the horizontal lines, that means pressure lines, the area called as a minus VdP work.
Okay, internal combustion engine, which work do you calculate? PdV work or minus VdP work? Any idea about that? Auto cycle, diesel cycle, which work do you calculate? PdV or minus VdP?
So PdV, sir.
So these engines are closed system or open system?
So engines are closed systems, sir.
You know what is closed system?
Yes, sir. Closed
Thermodynamic
system is
matter
nothing but
cannot go out.
yes, sir.
But in engine, so exhaust is going out, fuel is coming in.
So coming to reciprocating engines, I mean, internal combustion engines, taking that there is no when we are talking about the constant volume. So it seems like a closed system. When we're talking about exhaust and inlet valve, also valves are open. That is called an open system. So
If I talk about pressure cooker at home,
yes, sir.
you have seen pressure cooker at home.
Yes, sir.
Which process, heating process is which kind of process in pressure cooker? Constant volume or constant pressure?
The constant pressure, sir.
Is a closed system or open system?
So it's a closed system when it the pressure will be maintained some utmost. So I mean the dead weight will be acted on the pressure vessel, so it will be open. So after that it will cause a constant pressure system. So until that it will be constant volume process.
Okay, can you give some example where you use minus VDP work?
Yes, VDP work. Sir, I don't know exactly.
Okay, you know turbines and all? Power plant?
Yes, sir.
So the work used
Yes,
in
sir.
power plants and turbines is PDV or VDP? Minus VDP.
So, sir, I'm not sure about
Okay,
that.
Birappa, tell me, you know about reversible processes something?
Yes, sir.
Can you name some reversible processes?
Yes, sir. So reversible process, that means the cycle which repeats itself, that means the starting point and ending point is the same, that is called reversible cycle.
No, you name the reversible processes. Any name of reversible
Yeah,
processes.
okay, sir. So we have the isochoric process, isobaric, and isothermal, adiabatic, and reversible adiabatic we have. So and then polyotropic. These are the processes, sir.
So normally the work done in any engine is isentropic.
Yes, sir.
Auto, diesel, all these things. Any reason for that?
Isentropic, it means we have then entropy is a constant. That means that it means entropy is nothing but the disorderliness of molecules. When we act a pressure on a cylinder or it may be anything, so the disorderliness will be increases in the molecules of the inside of the cylinder. So that molecules will be the disorderliness will be coming from the rest. The molecules so try to come to rest position. So that will be changes.
Okay. Okay, let me give you the feedback, Birappa, of your thermodynamics part. Have you gone through that marathon video of thermodynamics, Birappa?
Yes, sir. I did.
Once, huh? You've gone through that once.
Yes, sir.
You need to go through that again, actually.
Yes, sir.
Because in that I have explained in detail what are the thermodynamic processes, zeroth law, thermometric property, what is the meaning of that. So all these questions were asked from that marathon video only. I've given
Yes,
you
sir.
example of minus VDP work also, PDB work also, and I've told you that internal combustion engines are open system, though displacement work in done in those kind of IC engine, and why that is done. So my advice is that you have a little bit studied compared to that day when we had mock interview in the campus, your preparation is better. But I think you need to listen to that marathon 2-3 times. So
Yes, sir.
whatever you have started now, listen to that marathon once again and come for the next technical snap, right?
Yes, sir.
I'll upload this video on our channel and I'll send you the link. Listen to this carefully where you have made the mistakes in the questions, right?
Okay, sir.
And keep revising more for that. Keep studying. Thermodynamics do 2-3 times and then come to IC engine. So thermodynamics and IC engine, if you compare, if you make these two okay, then your these two specs will be good, and then largely they will Hyundai will ask you these two subjects, right? If it is thermal domain.